Hello everyone, my name is Stav and I'd like to discuss an issue that we all seem to suffer from but never really talk about, bad abstractions. Before we start, let me just say a few words about myself. I'm a front-end developer, but I got to coding in a somewhat non-traditional way. I used to be a graphic designer, then I was a Flash developer, then one thing led to another, and today I want to also suggest a somewhat non-traditional way of looking at a very common problem. We all know this strange creature, a component so generic that no one understands what it does. We probably have it for ages in our code base, being passed along from senior to junior, or we might be just running into it for the first time in a new job while still learning everything. We don't really understand how to use it, but we do understand one thing: if we touch it, the whole project will break. Now, let's forget I said that for a minute and talk a little about abstractions. We have to have abstractions in order to write readable and maintainable code. Abstractions let us deal with complex mechanisms like simple things, so that we don't have to worry about their inner workings. So, for example, if you were to draw a cat, you probably do some generic lines like this. And you don't need any more than this, so that everyone understands what they see and never worry about what's under the hood, let alone make changes in it. So when we write code, we do it all the time. We want to use existing abstractions or write abstractions of our own. However, abstractions can be tricky and are hard to understand. Therefore, I can guarantee that you've encountered the following problem or even have it in your code as you're watching the video. So, somewhere in your code, there's a cat that is also a dog. Sometime in history, someone thought that they shared just enough features to be essentially the same thing. By the time we realize this abstraction is wrong, we're probably very far along into the feature or project, and now we have to support more and more bizarre use cases and behaviors. Now let's see how this thing rolls in real life. So let's say we have a very simple dialogue component. It gets a bunch of data, then spills it into a markup. Very lean, very simple. Later that day, though, we're asked to do something more. We want to support when some of the data is missing, or maybe we want to support types, because why not? We want the dialogue to be now of type warning or success or what have you. Fair enough. A week later, a new requirement shows up, as they always do. And now we have to take care of when we have an array of buttons instead of just one. Okay, we have the technology. Let's say now the product manager wants you to have the dialogue also being a form. Because, again, why not? We could send some inputs and stuff to it and present them. So our dialogue is a little less simple, but maybe a little smarter now. Cool, but I think you all know where this is going. So a random amount of time later, our code is no longer readable or maintainable. People are still scratching their head trying to figure it out. So this is the critical point. This is where we need to stop and identify the main thing that stops us from solving the problem or even diagnosing that we even have a problem. And here's the thing, like I said before, usually when we bump into that kind of code, it's like a million iterations into the process that we just saw, maybe a few years later, and when several people were involved. And if you remember that component from the beginning of the video, remember how I said it's been there for generations, just existing there? Existing code has a great effect on us. we stare at it, it stares back at us, and it's so confusing, it's so complicated, and the more confusing it is, and the more enigmatic it is, the more we tend to think it must have been the only solution to whatever problem it was there to solve. Somebody must have done a great job here. Who are we to fix it? So in economics, this kind of thing is called a sunk cost. It's like sitting through a bad movie just because we already paid for the ticket. So we won't get our money back, right? And if anything, we're just going to spend more money on popcorn, and not to mention losing 2 hours of our lives just because we insist on profiting from something we can't profit from. So that's a sunk cost. So I'd like to suggest something that, like I said, was a little non-traditional, but it might be the fastest and most efficient, and that is duplicate some code. When I say duplicate, I mean take this big abstraction that we just created and try to understand just what purposes it's trying to serve and how many, and then break it into just as many duplications so that you could research and see what parts of it are shared, what needs to be abstracted away and what doesn't. So let's sum up what we just saw. Abstractions are cool. We love them and we want to create them in order to write better code. However, we need to be careful as we tend to give them too many responsibilities over time. Then we end up with the opposite of what we wanted. We have a complicated code that no one understands. In that case, it would be worse than having just a duplication to begin with. So when that happens, we need to stop and rethink the code. It might not be serving us as well anymore. If it's not, take a step back and break it into duplications so that you can write a better abstractions. And now go make yourself a coffee because you did a good job. Remember that component from the beginning of the video. You should watch it carefully. We want components that know what they're doing, and we want you to know what your code is doing. Thank you.